Okay, next up we have much of the same, but you can see the difference this time is we have the expansion of k sine x minus alpha. Now it really doesn't change much, to be honest with you, okay? So really we just want to work our way through it. Okay, so the only difference this time is our expansion for sine is obviously different. So again, look at your formula sheet. And that's lifted directly from that. Okay, so sine a minus b is sine a cos b minus cos a sine b. So what we have is 5 sine x minus 2 cos x is k sine x cos alpha minus k cos x sine alpha. Right, let's divvy up what we have. So, change colours. Right. What do we have on this side? Right, sine x is, let's set them in blue. So sine x, where's the sine x? It's there. So you really need to look for where it is. So we have k cos alpha this time. So we have 5 is k cos alpha. Then we have our cos x's. Right, we have a minus 2 minus k sine alpha. Okay, so we actually have minus 2 is minus k sine alpha. We need to rewrite them. So 2 minuses make a positive, so they're going to cancel each other out. Put the signs on top, and then that one's fine. Once you've done that, it is just about turning out your steps. So 2 squared plus 5 squared square root 29. For our alpha, so we have k sine alpha is 2. K cos alpha is 5. Cancel them out. Tan alpha is 2 over 5. Everything's positive. We're going to do this anyway. So theta is tan to the minus 1 of 2 over 5, which is 21.9. So that is our alpha. And then again, always state your answer. So therefore, you can put equals, but we're looking for root 29 sine of x minus 21.8 degrees. So the only difference is it's your sine expansion this time the question's asked for. And when you're just matching them off, just really take care. Sine with sine, cos with cos. Exact same with number 6. You do so many, it feels a bit repetitive, but in the exam, obviously, you're only going to get one. Plus alpha this time. Okay, multiply it out. Look for your expansion. It doesn't start with a cos. They can use other letters apart from x and alpha, but mostly they're the most common ones. Okay, so match them off. Let's change my colours up. Right, cos x. Where's the cos x? It's there. So again, there's nothing there, so I like to put a 1 in. So 1. K sine alpha. Now if you don't have colours, you can use different shapes. I'll do that in this one. And negative 3. There's my sine x, k cos alpha. So negative root 3 is k cos alpha. Quick check what we have at the side. It's in the form of sine and cos. There's no negative in front of our k, so actually this one is good to go. Once you do that, turn them out right. 1 and minus root 3. If it's a non-calculator question, it's obviously going to be exact values. Chuck my negative to the side there. Okay, so we have sine over alpha, which is tan, and that gives you negative 1 over root 3. Okay, looking back here and here, so sine is positive, but cos was negative. That's there and there. Okay, your theta of 1 over root 3. What is this in? It's in radians. Okay, so we're going to do it in degrees and then we're going to go back to radians. So what gives you 1 over root 3 is 30. So alpha, what will quadrant me in? 180 minus 30, which is 150. Now back in terms of radians. Okay, so we're working in radians. Radians we know is 30 degrees is pi over 6. So it's going to be 5 pi over 6. So our answer, just look for a space to put it, therefore equals 4. No, square root of 4 is 2, not 4. So 2 sine x plus 5 pi over 6. And that's your answer. Okay, so if it's in radians, just watch out for that. Put it in degrees, 150. Pi over 30 we know is power. 30 degrees is power 6, so 150 is 5 times that. Right, final one on this page. Now you can see this one has got a 3x in it, don't get put off. Okay, it's actually very, very similar to the rest of it. So we're going to churn it out. So you can see your 3x's match in here. So that's your A. If you don't like doing alphas, do A's. Okay, and that's equal to this. Oops. Okay, here we are. So, what we're going to do is match it out. Now, this time we are matching 3x's. So 3x with 3x, 5, k cos alpha. Cos 3x's, we have 12 minus k there, watch out for your minuses. So we have 12 equals minus k sine alpha. Not in the right form, so I'm going to do that. So first of all, I want my negative to be my 12. And I want my 5 and my cos to be underneath. Okay, so we have that. So really just take care of writing down your formulas. Sine from your formula sheet, minus stays a minus, and then match it out like we've been doing for the last so many examples, and then we get to this point. Once you get to that point, just turn it out. Okay, this one is calculator. It is a Pythagorean triple again, so it's 13. So what we got, so k sine alpha is negative 12 over, zoom in a bit, k cos alpha is 5, they cancel, tan alpha is negative 12 over 5. Okay, go back to your two steps here. So sine is negative there, and cos is positive there and there. We're working in degrees this time, and it's calculator, so theta tan to minus 1 of 12 over 5. And we get 67.4. So alpha, what quadrant am I in? That one, so 360 minus 67.4 is 292.6 degrees. So finally, answer, therefore, what do we have? K 13 sine. Again, look back up at the question, it's a 3x minus alpha. If you forget about the degrees, don't worry. The main thing is that we've related it back to the question. So that is your wave function. So sine and cosine expansions, then the rest of it is just working through your steps.